Hi, today we are doing problem unique elements in sorted array. So we are given an array which is in sorted order and we have to return all the number of unique elements in it. So 1, 2, 3, 4, 5 are the unique elements in this array A. We return 5. What is the naive approach? We basically assign all the elements into the set, all the elements in the set, and you know that set stores all the elements, only keeps the unique elements, right? And we return its length. In C++, we have to insert every element in the unordered set and then we return its size. Okay. Now in optimal approach, let us look at this approach. So in the previous approach, we had to use a set, but we don't want to have any space complexity. So does this problem, this approach doesn't require a set. So let's see how that works. So we have elements 1, 2, 3, 3, 3, 4, 5, 5. Let me write them 3, 4, double 5. So what we do is we say that the current element is at this element is the current element. Okay, this element at 0th index. 0, 1, 2, 3, 4, 5, 6, 7. Okay, then we start I from first index and we check whether AI is equals to current. So if it is not equals to current, which is the case, so current is pointing to this 1. Current is pointing to this element 1 and 2 is different from it. So what we do is we say that we have found our second unique element. So at A0, which is the first element was unique, and then it was 1, and then we have found at AI, at this ith index we have found 2, which is not equals to current. So we have found our second unique element. So unique is 2. And we assign this current to 2. So we say that the current element that we are basically tracking as the duplicates of is 2. So current is 2. Then we move this I pointer. Again we encounter 3. So at A of 2 we have 3. This is not equals to current. So we say we have found our third unique element. Okay, and we move this current, we basically make current equals to 3. Then we move this I, and at third index we have 3, which is equals to current. So this condition fails. This condition fails. And this condition fails, we just keep moving the I ahead. You can see what is happening because we have 3, only 3 is coming, so we don't have to increment unique, because we are not getting any element which is different than 3, so we don't have to increment it, don't have to, right? So now this I goes to 5 and we have encountered another different element, so we increment our unique count to 4 and we set current as 4. Then we increment I and we have encountered 5, which is different than current. So current is assigned value 5 and we increment unique 2 by 1, which is 5. And then I goes to 7th index. It is this if condition fails, basically we 5 is equals to the current element, and then I goes to n and we exit the loop. So unique number of unique elements are 5. 1, 2, 1, 2, 3, 4, 5. let me show you another example. Okay, so 1 2 2, let's say 1 1 2 2 3 3 will just become a little easier. 3 3 4 4. So current is at 1, unique is 1. Okay, we are looking at I is pointing to, let's say, initially this element. So, so I starts from 1, sorry, I starts from 1. We check whether this 1 is equals to current. So current is pointing to 1. So this 1 is in continuation, right? So until 1 is in continuation, we don't need to do anything. Once we have encountered another element, we say that now 2 has started occurring, right? We say that from now on we are tracking 2, so current is equals to 2. So until we keep getting 2, we don't need to do anything, we don't need to increment this unique elements, right? So this is 2, and just for example, let us say this is also, so at this index we have also 2. Then this I is moved one step ahead, again we have 2, so we don't do anything. Then this I is moved ahead, now we have encountered element other than 2. So what we do is we increment this unique count by 1 and say that now we are tracking the element at this index, which is 3. So until forward in the array we will keep getting 3, we don't have to increment the unique. Okay, so now in this case we have a 4, so we again increment unique count to 4 by 1, so 4. We set current to 4, and here what we do is we now increment I, and in this case it is same as current value, so we don't do anything. Then this I is incremented again and it has reached the end of array, so we say that the number of unique elements in the array is 4. 1 2 3 4. Okay, so this runs in big O and time complexity. Okay, and there is no space that we have taken. So space complexity big O of 1. So, okay, bye bye.